Morning, everyone. So for this week of week 11, we are going to be defining translations. Now, as a quick preview, what we did last week was we overviewed reflections, and then the week before we did a little bit of preview of all three different transformations. So this week we're focusing on translations, and I'm just going to go ahead and jump right into it. For this week, if you are attending the live sessions, you're going to be asked the questions live in class. You're going to be able to show your screen, and then that's how you'll get engagement, participation, and progression points. You will also be responsible for an assessment assignment. Now, if you're not tuning into live sessions, then you are watching this video through an Edpuzzle. And then through the Edpuzzle, it's going to be asking questions as if I were in a real live class. You're going to have to send screenshots to show me your work and then still be responsible for the assessments. So to jump right in, we are looking at the notice and wonders. So, when you're looking at this, knowing that we're talking about transformations and specifically translations, remember that translations is what I want you to try to remember is SL for slide, okay? For noticing and wondering, what do you notice? What do you wonder? Look at this a little bit and then, take the time to pause the video and then jot down some thoughts. What are you seeing? After getting a chance to write down some of your thoughts, you could have said a number of things. You could have said something as if, there are two similar and congruent triangles. You can say that there's an arrow that has a direction. You can notice that one triangle has letters, the other one does not. There are different things that you can say, but I do want to make sure that you are alluding to the fact that there is an original triangle, there is a line, and that there's another triangle that looks like it corresponds with the distance and direction of that line. If you didn't get all of that, that's okay, but hopefully now you can kind of align yourself to thinking about those talking points. So here you have a slew of different points. Now for this problem, we're just going to take one problem at a time. So it says after translation, the image of V is W. So of all these points, V and W are on the very left side. Find at least three other points that are taken to be a labeled point by that translation. So what I want you to imagine is right here, we've already done translations before where I think it was when we did 10.2, 10.3, we found different points, there were different line segments and vectors, and we were able to translate them. Here, we obviously see that there are no vectors, but we know that V and W were translated in a direction. So what we want to do is find other points that correspond with the direction and the distance of V to W. Now, there's not going to be any way that you're going to know this exactly unless you take, a protractor and a measuring line and then put it up to your computer, but we can kind of see some similarities. I think looking at it right now, you can see that V and W kind of look similar to Z to Y, or maybe to U to R. T to P maybe one, M to J maybe one, J to E maybe one, K to G maybe one. Now I always say maybe L to F, I to C, G to B, E to A. Obviously all of these are coming out at me because I'm noticing, I'm trying to find lines that look roughly the same, roughly similar to each other. If I can expand my image, you can kind of see that if you go to VW, there it is right there. That's probably similar to, E to J, all the other distances that I pointed out. Okay, so the word conjecture, that was a vocab word in before, and that was a conjecture, was things that we knew and understood, but we didn't know exactly why. We didn't have a rule. And I believe we did conjectures in the past about congruency. So, when we think we know, when we're assuming that these are similar, why do we think that V to W is the same distance as E to A, J to E, T to P, U to R? Some conjectures that you can think about, or some assumptions that you can think about, and observations you can say are, they look like they're the exact same distance. They look like they're the same angle. If I were to draw a line with V and U, I should be able to pick up that line and it would be on the same dots as Z to Y, as U to R, as T to P, as M to J, J to E, E to A. Those are all may not be right. Some of those may be accurate, some of those may not be, but that's the whole point, is that if I take a line and you move it from dot to dot to dot, it should be the exact same distance, exact same angle, okay? That's when you want to think about the vectors. That's when we had vectors for 2 lessons ago for 10.2 and 10.3. Now it says, in a new translation, the image of V is Z. So let's stop for a minute. V right here is Z. So now it's going in the opposite direction and a little bit further. V goes to Z. Find at least 3 other points that are taken to be labeled by point in that new translation. So if we're looking at V to Z, maybe Q to U is that. Maybe G to P is that. Maybe G to N is that. This one I will say is a little bit harder because it takes more distance, and this is a little bit further away from everything else. But we don't know, right? However, for number 4, are your conjectures still true for the new translation? Think about the things that we wanted to think about. We wanted to think about that the distance was going to be the same, that the angles were going to be the same, that they were going to be in different areas. But ideally, if you trace a line, a vector line, that you moved it from point to point to point, it should still satisfy the same distance of the 2 endpoints. So after coming through this problem and hearing me, talk through these things, I want you to imagine if you had these dots on your on a piece of paper, you had a ruler, and then that ruler was able to, copy and paste different lines. These lines should not change the angle. You should simply be able to pick it up, move it somewhere else, and they should match. So those are the outcomes of translation. All right, so when we're translating triangles, this is what we're going to be doing. We're going to be, once again, playing on GeoGebra, and then what I want you to do is, if you are watching this Edpuzzle, not only are you completing this video, but you are going to have to stop this at the end of the completion, screenshot it, and upload it to Google Classroom. All right, so moving on. Number 1, translate the triangle ABC by the directed line segment from A to C. So this is what I want to take piece by piece. A directed line segment, let me scroll down, right here. A line segment with an arrow and one specifying direction. Now, 2 lessons ago, we learned that was called a vector. So the thing is, it's bolding it for us because we don't have a vector that shows us A to C, okay? We need to translate this triangle by the line segment or directed line segment A to C. We don't have that. So obviously there are no vector tools that we see that we can create, but if you click the line tool, you can create a vector. And we're creating a vector from A to C. So let's do that first, okay? Once we create the line segment or the vector, we can now translate the triangle. So once again, we don't see the translate tool, but this is the reflection tool. So what this actually is a transformation tool, because you're going to see it has rotate and reflect and what we want, which is translate. So select translate, select object, and then vector. So let's select the triangle, and then let's select the vector. Now, I'll show you different ways that you can do this because I did a different way and I was like, oh, this part makes sense. So let's pretend I did not know to translate the triangle, but I wanted to do it piece by piece and create my own triangle. I can select the translate tool, select point A, and then select the vector. Select point B, select the vector, select point C, and select the vector. And then I can make a polygon, and I can create these 3 points together. There we go. So what I just did the long way is the exact same thing as, which you all can do as well, as translating the entire triangle and then moving it by the vector, okay? So now I'm just showing you 2 different ways that you can do it. Okay, so this is where we're going to pause for a minute, and you're going to answer and reflect, what is the relationship between line B and C and line B prime, C prime, explain the reasoning. So this is going to quickly pause, but it's going to ask, what's the relationship between this line and then this line? I will also, I'm going to bold, make it a different color, just so you all can, I don't know if this is actually going to change. Let's see. Okay, so those 2 dark black lines, what's the relationship between those? Pause this video. Okay, so I'm not necessarily looking for right and wrong answers. I'm just looking to see if you're on the right track. Once again, when we're asking for the relationship, this kind of hints to the conjectures that we kind of pointed out at the beginning. So some things you could have said that would have been on the right track are the line segment B to C and B prime C prime are the same angle. You can say that there's the same length, that they're congruent. Something you also could have said is that they are parallel. Imagine if this line is moving by that vector, it's just moving the same distance, but it's keeping the same angle measurement, right? That means that this vector should be the same distance from here to here as it is from here to here. To prove that, not to make anything too confusing, I'm going to undo the dark line so you can see. So to prove that, I'm going to, we already did this, but if we move point B by this, it makes that 1. If we move point C by this vector, it's going to make point 1. So what you're going to notice is that if this is the same distance, this has to be the same distance. These are the same distance from each other. So the lines that's created has to be the same distance as well. That means parallel. All right. So how does the length of segment BC compare between the length of segment B prime, C prime? Explain the reasoning. Same thing. I'm not going to pause this video because I'm going to kind of keep it kind of short, but the line segment has to be the same length because they're from the same original points. All right, next one. Translate segment DE by directed line segment W. So here we have directed line segment or vector W. We don't need to create a vector. Label the new endpoints D prime and E prime. Okay, so a few things. Let's show the complicated way or the long way. The long way is that we translate point D by the W vector and point E by the W vector, and then we can create a line segment between both. You can do that, or you can do translate by vector, and the whole object is instead this line segment, and then you're selecting vector W. Move it over. Now we do have to use a line segment tool to connect D prime to E prime. So line segment, connect D to D prime, collect E to E prime, boom, done. What kind of shape did you draw? What property does it have? Explain the reasoning. Pause this video, answer the question. Okay, so after you watch the video, there should be some thoughts that you should have. Some thoughts that you should have is that, what kind of shape did I draw? You can say something that has four sides. It could be, something that looks similar to a diamond, but not quite. It looks like a square if you push it over on the top. You can say many things, but ideally what this is called is a parallelogram, okay? Or you can say a quadrilateral, or you can just say a four-sided shape. Some properties that it does have is that just simply by looking at it, you should know that the distance between D to E and D prime to E prime are the same. So the two sides have to be the same. That also means that since each point was translated by vector W, that this distance from D to D prime, it has to be the same distance as E to E prime. So what you're looking at is that the tops are going to be the same as the sides. The tops are going to be the same and the sides have to be the same. So you have two pairs of congruent parallel line segments, which is what a parallelogram is. Okay, so that is really it for today. Remember that defining different parts of transformations is just a little sneak peek. We have to understand this, we have to really practice it really well, and then we can kind of move on to something bigger, more complicated, and harder. So before we move on, as a summary, a directed line segment, that's a vector. Simple as that. You can also scroll down and see your summary as well. A translation is when you move a point in a direction of a line, okay? They're always going to be parallel. Let's see here. More precisely, a translation of a point A along the directed line segment is a transformation that takes A to A prime, so that the directed line segment is parallel to the... So basically, that when you connect the line from original to copy, so A to A prime, this line that's created is the same parallel distance between the vector that's chosen, okay? So here, you can see that my vector is V. I'm going to zoom in. My vector right here for this problem is V. I have this original blue triangle. I move it along vector V, and I have this orange triangle. Then I'm like, okay, connect all the endpoints. So C to C prime, D to D prime, E to E prime. And what you should notice is all of those lines that I'm connecting from original to copy is all parallel to V right here. Okay. So congruent, we already know. Directed line segment, that is a vector. An image is an image. Remember that the original is the original and the prime is the copy. And the reflection is simply when you can create right here, what you can see. Oh, no, that's a reflection. So reflection is when you create perpendicular lines because it's the same distance from a reflected line. But what we did is a transformation where instead they're parallel, okay? Alrighty, so now what I kind of want to do is, this is something that you will not have to turn in, but we are going to still go over it in class and as well on the live session. So the first practice problem, I would typically do this on assessments, but assessments was really complicated, and it wouldn't let you look at everything both ends, and I would rather show you rather than you practice it. So looking at the first practice problem, here we have 4 different translations. And what I'm going to do, let's see if I can make this. I'm going to crop and move. Yep, that's what I'm going to do. Okay. All right. Perfect. Okay, so here, this is what I have. I have different translations, okay? We're going to do one translation at a time. And we are only going to be looking at, although I cut it off, P to Q. So if we're looking at P to Q, oh, did I X out of the, okay. So polygon P transforms to polygon Q. So think about Q as a prime and P as the original, even though P starts with prime. That's annoying. Anyways, P to Q. So to go from P to Q, I have to move right. So which one of these images shows me that I'm moving right? It's either A or either D. Now, what I will say is these images right here are definitely shifted, so I don't know which one is more correct, but if you go back to the original problem, P to Q, this is also another one that goes from P to Q. Okay, let's do this. So we have 2 translations, translation 1 and translation 2. But notice that both of these are when P has to shift right to create Q. But this one's a lot closer than this one is. So if you're simply looking at the different choices, just by process of elimination, you should come to the a conclusion that A matches with this right here. Okay, I'm going to kind of set it over so you can see. That's A. And that D matches I just lost my internet. Come on now. Oh no. That D, okay, anyways, that D matches with translation number 2. So let's move on. Will it let me move this? Ha, 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 ha. Okay, excuse me. So D matches with translation number 2. I'm going to go ahead and move that over right here. Okay, so we can kind of see that. Now we're going to be looking at translation number 3. So translation number 3, you can see that it kind of comes at an angle, okay? So from P to Q, first of all, from P to Q, I have to move left, but I also have to move a little bit up. So if I have to move left and up, my diagonal is going to go from here to here. So this is exactly what my line should look like. From this point to this point is what my vector or directed line segment would be. I'm sorry, I'm scooting in and out so ferociously. Okay, so just by looking at it, I should see that the only one that moves in that direction is C, or that directed line segment A. So I can move it over a little bit, and you can kind of see how it goes from this point to that point, P to Q. And by process of elimination, we are only left with B as an option, but let's go ahead and move it and compare it in translation number 4 and see what that looks like. So if we're looking at translation number 4, P to Q means going a little bit down. Oops. Where did that go? Okay. It has to go a little bit down and a little bit to the right. So B will be the one that matches. There we go. So here you can see, oh my dear, this is going to be so fidgety. Nope. Okay, I'm just trying to zoom out, not too much. Okay, Hopefully you get the point. If you're coming to live sessions, you're going to get extra credit, and then you're going to be able to see this once again in live time. All right, so that is the lesson for today. I'm going to go ahead and then, I'm going to go ahead and post this assignment on an Edpuzzle. You're going to be completing the Edpuzzle. Just make sure that before you complete the Edpuzzle, what you need to do if you're watching this video is that you need to go back to your lesson. You need to take a screenshot. Let's go here. Take a screenshot of the triangle that you translated and then upload that to this assignment. If you do not know how to take a screenshot, you go to the 3 dots under your Chromebook tab or under the X, go to More Tools, then select Take Screenshot. It will automatically go onto your files and then you're able to upload it. If you do not have a Chromebook, you can use simply search how do I take a screenshot on my computer, and then you should be able to kind of find out from there. Everyone has a different computer, so I can't really tell you what to do, but something that you can try is hold shift, and then hold control, and then hold F4 all at the same time, and then you should be able to take a screenshot. Alrighty, y'all, thank you.